What's going on YouTube? This is IPSEC. We're doing Wifinetic from HackThebox, which has a technology I've never seen before used in a VM, and that is Wi-Fi. And that's not to say I haven't seen someone hook up a wireless dongle, pass it to the VM, and get Wi-Fi. This actually has full hardware simulation, so it has a Wi-Fi network built into this box with no hardware component, which is pretty cool, especially because the root step involves attacking WPS, which is Wi-Fi protected setup. It's also something I didn't have much familiar in with it before this box. I always thought that you just entered the PIN and it magically let you on the network. For some reason, I didn't think you entered the PIN and it sent you the wireless pre-shared key back for you to then log in. So we'll go do that, and then we're going to spend a lot of time in the Beyond Root showing a fun tactic for creating a password spray program for SU, along with explaining exactly how WPS works and its flaws, because if you ever see WPS enabled, you should always disable it. It's a horrible service. So with that being said, let's jump in. As always, we start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it Wifinetic, then the IP address of 10.10.11.247. This can take some time to run, so I've already ran it. Looking at the results, we have 3 ports open. I know that right away because we scanned 1000 and there's 997 that are closed. The first port is FTP on port 21, and its version tells us it's VSFTPD version 303. And I know this version is not vulnerable just because I've looked it up 100 times, but anonymous FTP login is allowed, and we have a list of files that are on the web server, all uploaded July 31st. We also have SSH on the box. It is listening on port 22 and a Ubuntu server. Then we also have port 53, which just says open. It's TCP wrapped. Chances are this is going to be a DNS server. But let's go take a look at the FTP server. And to download all those files, I'm going to use wget just because it has a recursive option and lets me download everything at once. So FTP 10.10.11.127 or 247. And we see it logs in, and then it's going to go ahead and download everything. If we go up, I should move the actual directory into the FTP. And the reason why I created the FTP directory is just to stay organized so I know these files came from FTP. Then we have a tar archive, which probably we should unarchive and look at it. But first, I'm going to look at all the PDFs and the .txt file. I'm going to look at .txt first. And if we do it, it looks like it has a roadmap of something, right? I don't want to read all this. We can see something like OpenWRT, which is a open source wireless router, and a lot of things about testing Wi-Fi. We also have a bunch of PDFs. The first thing I like doing on PDFs is running exiftool against them. This is going to look at the metadata, and potentially we can get some authors or how these were created. We can see it is a Google Docs renderer, and then the title is Wifinetic breadcrumb documentation on project open wrt.pdf. And looking at them all, it doesn't look like any interesting data is in the metadata. But let's go and actually open up some of those PDFs. I think I could just run the open command, right? I don't have to go to a file browser. I can do open. And then we can see this PDF. There is a potential username, Samantha Wood 93. And glancing over this, nothing of that really seemed too interesting. It's just about well-being of employees. But I'm going to start creating a users list, and I should have called like users.text. So we have a list of valid usernames. We can also look at project Great Migration. And this is just a blank presentation. There's potentially a email info@wifinetic.htb and some social media stuff that doesn't work. Then let's go to project openwrt.pdf. And we have a distribution list, the manager, and that's talking about migrating to a new Wi-Fi system. But we also have another username, so I'm going to add that to my documentation. So now let's go take a look at this tar archive. I'm going to make a directory called backup, and let's go in it, and then do tar xvf on the archive. And there's only an Etsy directory. So let's go into Etsy. And let's see. this looks like it's just Etsy of a Linux system. We have like group, passwd, and there is a user called netadmin. This is a non-default user, so I'm also going to add netadmin into users.txt. And let's see, there is dropbear, and dropbear is a SSH server that I see on just like a lot of IoT devices or just random devices. They don't use SSHD, they use dropbear for whatever reason. Let's see, there is shells. It is using bin ash. Let's see, let's go into config. There's always good things in config. And based upon it saying NFT tables, I'm assuming this is like a BSD server, right? Because Linux uses IP tables, BSD uses NF tables. I think that's network filter tables. There's a DHCP. Nothing too interesting there. There is a dropbear config. We can see open port 22. Dropbear doesn't really interest me that much because the nmap scan, if we looked at it, has, let's see, where is it? It's using OpenSSH, so this is SSHD. It would say dropbear here if it was a dropbear server. Look at firewall. Looks like a basic firewall. Wireless is interesting. And we have a potential password, very unique Wi-Fi password 1. So what I'm going to do is spray all my current users with this password. And the only login portal we have right now is SSH. So I'll do CrackMapExec, SSH, 10.10.11.247-u, users.txt-p, and put in this password. If I was just guessing, I would probably try just netadmin first because the network admin likely is setting up this Wi-Fi information, right? And we can see netadmin can log in and he has shell access to this box. So let's do SSH netadmin at 10.10.11.247, paste in that password, and we get logged in. So the first thing I always like looking at is just what's in my home directory. So I'm going to do a find.-type f. Doesn't look like there's any interesting files. The next thing I want to look at is if I'm in like a container or something, I can do a lsla on /. Everything looks like a standard Linux directory listing. We could also look at IPA and look at ETH0, and this is the IP address I SSH to, so there's nothing funny with like NAT going on where I SSH to one IP and land into another one. The interesting thing though is I see a bunch of wireless interfaces. We have WLAN 0, 1, and 2, and then HWSIM. I'm guessing this is some hardware simulation for all these wireless LANs. There's also Mon0, which is a monitor interface. It can't send packets, but it can receive all the packets. It's often used when you're doing like arrow dump or TCP dump to list all the things that are going on in the wireless spectrum. So looking at this, both these wireless interfaces are on the same network adapter. My first bet is I want to look at what's listening to see if there's any unique services listening on one of the wireless networks, and nothing interesting at all. These are all the ports that we had seen. So I'm going to go and run LinPeas. So let's make dir www, go in that, and I'm going to copy opt peas, LinPeas over here. Let's start up a web server. So http.server, and then we can curl 10.10.14.8, port 8000, linpeas.sh. We forgot to pipe it over to bash. So this is going to take a little bit of time to run, probably about 2 to 3 minutes. So I'm going to pause the video and we will resume when this is done. Okay, so LinPeas has finished. Let's go look at the results. And let's see. It's talking about system information. I'm just glancing over whenever I see new titles or when I see a lot of red. Right? There's a lot of information in LinPeas that's just not interesting. And whenever it says a kernel exploit, I typically ignore these until the very last thing because they are unreliable, and also checking it isn't the most reliable. I know it's not vulnerable to this whole set UID screen thing. It's just not a reliable tool, right? So that's always going to be the last. Always look at all the recon before you go jumping down a rabbit hole unless you're 100% positive. So here it's listing a bunch of processes, and this is an interesting thing that I didn't know LinPeas did. It must be one of the newer features. When you have a process that has a special capability, it is listing it out here. So this is a bit better than just running like PS on a thing, right? It's doing that type of check. Let's see, binary process, parent process IDs. We can see that process 8566 with parent ID is ran by user netadmin, but the parent process is root. So I kind of want to look at what this process is. Let's see. vnotes. Let's just do process this because that could be something. Root is starting a process that then gets owned by netadmin. Let's see, we have no credentials in memory, of course, because we're not root, we can't even look at that. System dpath.service files, nothing interesting there. System timers, these all look like their default ones. Socket files, this all is a lot of noise to me, just because if I saw it, I don't know how to exploit it right away. So that goes on the back burner, just like kernel exploits, right? PGP keys, PKExec, super users, users with the console. There's definitely a lot of users. One user root. We have netadmin. The purple one is us. Users and groups. Login, last login, login each user. Useful software that's on the box. So we have netcat LXC. We should check if we're a member of the LXC group. I don't believe I did that, but I think it would have stood out earlier on in this LinPeas thing. If we were, then we can prevest that way through the LXC. rsync host APD file. So it found this, but this is in the example, so it's probably not going to have any good information with it. Nothing LDAP. We do have root login is permitted in SSH, which is interesting. We have the SSH config. Let's see, PAM file, tmux. It's looking at FTP files, nothing interesting there. There is a lot of things that LinPeas checks. Files with interesting permissions. This is going to be like set UID files. All these look like they are standard, so nothing interesting there. Same with all the set GID files. LOD SO looks normal. This is going to be capabilities. And the first file I see with a unique capability is Reaver. And this is a wireless attack tool. So this one definitely stands out. I'm going to stop looking at things because this is extremely, extremely odd. Reaver has CapNet raw, which means it has full access over the network sockets. So if we look at Reaver, let's see, what is its description? It is a specific tool to attack WPS, which should be disabled in all routers just because it has so many various vulnerabilities. We have to specify the interface and the BSS ID of the target access point. So what I'm going to do is a IW, I'm going to hit tab to look at all the wireless things. And I think it's IW list. It is. And we can do IW list scan. And what this is going to do is scan for Wi-Fi networks, and it's going to get the open WRT network and its BSS ID, which is just O2 and the rest O's. So now we can run Reaver. So if we run Reaver, we specify the monitor interface. We know is mon0 based upon just the IP address information. So we can do Reaver-I mon0. And what was the other thing we needed? The BSS ID with a -B. And when we run it, let's see. I did not say 0, I just said mon. Retrieve beacon, and it got the WPS pin, and got the pre-shared key, which is the WPA2 password for this network. We could try various users to see if another password spray, right? So if I cat etc passwd, we have lots of users that it could go to. We could just try root first, and we get lucky and we got root. And that is the box, but we're not going to stop there because this video has been really short. Let's go much deeper and look at this. So the first thing I want to look at is, let's look at password spraying and build something that's a little bit better than just spraying. And then I'm going to look into exactly how that whole WPS attack worked, right? So we had a lot of users on this box. We got lucky and just got root right away, but how would we spray the same password across all these users? So we can create a quick bash script for that. So I'm just going to do vi, and then I'm going to call this spray.sh. And the first thing we want to do is build a list of all the users, right? And we could just do users is equal to cat etc passwd, then awk field separator : print 1. We could do that, but that's not exactly elegant, right? Because if we just run this command, it's going to get a ton of users. In reality, we just want the users that end with, or that the passwd line ends in sh, because those are going to be the ones with a shell. If we get rid of the awk, you can see those users on my system. Postgres has bin bash, ipsec, and root. All the shells really always end in sh. There's like ash, there's sh, there's dash, there's bash. So ending a line in sh is relatively safe for finding active users on the box. I still don't like this just because we're going to use cat, we're going to use grep, and we're going to use awk. We could do this all in one command. So awk does have a thing called nf, which is going to be the very last field. And I think if we say sh like this, when you do this / whatever, that's going to be regex and etc passwd. Let's see, that did not work. How do I do this? Do I have to do it in single quotes? Yeah, single quotes. We can do the same thing as our grep. So we got rid of both cat and grep, but now we want to only get the first field. So I'm going to do awk-f : so that's going to be the field separator : and then we're going to use if nf, which is the very last field, is somewhat equal to sh. This is going to be like a regular expression, and then print 1, which is going to be the first field. If we do that on etc passwd, we get error because we did not close out the squiggly bracket. So now we're just doing all this with one command or one binary, which is a bit less noisy if someone's looking at command out, like what binaries are ran on a computer. Also, maybe this stands out because if someone's looking at all the processes ran on a box, no administrator is probably going to type this command unless they're super familiar with awk. They're probably going to do all those pipes, so maybe the pipes doesn't stand out as much. But I like just using one binary when I can, because maybe I don't have access to grep for whatever reason, right? So now let's do for user in users. So we're going to loop through every user, and then all we want to do is echo the password. So I'm going to do $1, which is going to be the very first sysargv. So when we execute this script, we're going to give it one argument, and that's going to be that. I'm going to say a timeout of 2 seconds. So if this next command takes more than 2 seconds to run, stop. We're going to do an su on the user, and then a -c, who am I? And then pipe the output to dev null, or pipe errors to dev null. And then done. And I think that's all we have to do. So if I move this spray.sh over to the box, so let's just call this v spray.sh, put this in, and let's see, what was the password? Do we have it still easily? There we go. What is real and what is not with some numbers. So now if I run spray.sh with the thing, it immediately says root because that is the first account on the box and that's the valid password. And that's going to keep trying all the other users and it doesn't get anything. We can Control Z and PSEF grep spray, kill 4379 or 43679. Do we still have it running? Maybe -9. There we go. Now it's killed. So let's improve this a little bit. We could look at all the return codes, right? So if I, let's do it's on the SSH thing. Let's do v spray. If we just echo, let's see, we'll do user and then $? This is going to be the exit code of the last command. And now I'm going to run that spray again. And we see root 0, netadmin 124, which is an error, S Johnson 88, error. So 0 was success. So we can see it trying all the users. So let's do a kill -9, 43809 to make sure that's dead. And what I want to do now is say if the last exit code is equal to 0, then we could exit. And that will end the script, right? But what I'm actually going to do is say return. And we're going to make this into a function. So I'm going to highlight everything. And we're going to call this do spray. And I forgot to indent this. And then this could be do spray 1 like that. And the whole reason I like doing it this way is we could both copy the script. So if I just copy this, we move it over. I need a set paste. There we go. We can do bash spray.sh, put in the password, and it will work, which it won't because typos. If, let's see, how would I screw this up? Do I need a space after this? There we go. So immediately we get root and it exits because we got a valid user. But what if I didn't want to touch disk? Let's fix it on my computer. Since this is a bash function, let's see, let's just rmspray.sh. We can cat spray. We could just grab this function and then paste it in here. And now I have a do spray command, and I can paste this. And that just added the bash command to spray users so we didn't have to touch disk at all. And the whole reason I did this all in bash, I probably should have said it earlier, is lack of dependencies. We could upload a program called sucrack. We've done it in a previous video, but that's a C program. Sometimes you compile in your box, you upload it, and then it doesn't work, right? So the whole reason I did this in bash is just there's no dependencies. So with that being said, I realized I wanted to look at what process 8469 was real quick. And that's just SSHD. So that's why that makes sense. When we were in LinPeas, it said there was a process owned by netadmin that had a parent process ID of root. And looking at it, we can see it's because I came from SSH, because the SSH service is root. I logged in, it downgrades me to netadmin and gives me a shell. So now let's finish this video off by talking about WPS. If you wanted to look at that spray script, I'm going to put it on my GitHub somewhere, but there it is for you if you want to copy it. So let's run that Reaver command again, because a lot of magic happened under the hood that I didn't explain. I don't even think I explained what WPS was, which is just a old technology to authenticate to wireless networks. It was created, I think, in 2013. There were a few forms of it, like a push button. You may see like a WPS button on your router. You push it, and then it enables it. There's this that just stays active. There's near field communication that use different wireless protocols like RFID. There was USB. It was a large protocol, but a lot of old routers just enabled it by default, and it had a lot of security vulnerabilities in it that were very questionable. If this was just a 8-digit pin that had proper timeouts, it wouldn't be that bad, especially if that pin rolled every hour or so and you couldn't just brute force the whole key space. But there are two big flaws to this technology. The first one is it's not really an 8-digit pin. This last digit is just a checksum. I think the whole purpose of it was a user types this and then it tells them they typed it wrong. They made a typo, and they didn't even have to send the request to the router because it has a built-in checksum, kind of like the LUN algorithm of credit cards. And when I first tried to figure out this checksum, I asked ChatGPT, and it was wrong. It's just saying essentially add all the previous numbers and then mod 10, right? So if we did that, so we got 1, now it becomes 3 because we added 2, 6, 10, 15, 21, 28. Mod 10 would be 8, or what it was saying was actually minus. I'm trying to get my browser back on screen. It doesn't look like it works, but it was saying 10 minus that pin calculation mod 10. So essentially this would be 2 because it would be 8 mod 10. And that's wrong. I went in, actually Googled a lot of things, Googled a WPS generator. If we just Google, let's see, if I open up Firefox, see if it loads for me. We could Google it, but essentially you have to multiply every other digit by 3 and then do that. And that's what ChatGPT was missing. So if we Google like WPS generator Python, there's this. And we could run it. Let's just grab this, v notes, whoops. Okay. So we want to calculate it. I'm just going to multiply every other one by 3. So that'd be 3, 2, 9. 4 times 3 is 12, but I'm going to mod 10 it because every 10 doesn't matter. So I'm just going to put 2. Then let's see, we multiply, no, multiply. Oh, actually, wasn't supposed to multiply that one. 3 times 5 is 15, but again, I'm going to drop the 10 off of it. Then 6, and then 3 times 7 is 21. So now let's do this. So we got 3 plus 2, that's going to be 5. Then plus 9, we're at 14, 18, 23, 29, 0. So that works. So that is exactly how the WPS generator worked. But that is not the only flaw. Going from 8 digits to 7 digits isn't a killer flaw. It also suffers from what Microsoft did with LM hashes, not NTLM, the precursor to that, which was just landman. And it's actually split up into 2. So how this works is you only need to know the first 4 in order to validate this is correct. And then you just need to know the last 3. So instead of doing like 10 to the 8th, it is 10 to the 4th plus 10 to the 3rd, which is an like tremendously lower amount of hashes. And we can prove that Reaver is doing this by, if we just run Reaver and add -VV, we'll see all the messages. And that's where M1, M2, M3, and all these stuff comes into play. This is kind of like a Diffie-Hellman exchange, getting like perfect forward secrecy working. And then M4, this is the message that we're sending with 1, 2, 3, 4. If this sends a Nack back, then it's wrong. If it just keeps going, then it's correct. So this one hash only is the first 4 digits. If I specify, let's see, I think there's a way to specify a pin, right? -P. 1, 2, 3, 4, 5, 6, 7, 0 is the first pin that Reaver ever chooses. So let's get this wrong. Let's do 4, 3, 2, 1, then 5, 6, 7, 0. And we see, let's see, there we go. So we went to message 4, we got a Nack back, so we know 1, 2, 3, 4 is wrong, or 4, 3, 2, 1 is wrong. If we do 1, 2, 3, 4, 5, 6, let's do 8, 0. See what happens here. And we see it goes past message 4 and goes to message 5 and then message 6. This is the one where we're sending this second half of the password, and it says it is wrong. So that is exactly how this tool works. Reaver, by default, always chooses 1, 2, 3, 4, 5, 6, 7, 0 first. So if we wanted to, we could go etc WPA and permission denied. Let's actually get the root password again. 1, 2, 3, 4, 5, 6, 7, 0 is the pin. Let's escalate to root so we can change exactly how this is working and get a different pin. So set that up. CD etc WPA supplicant. It's WPA Let's see, how is this generating pin? Let's just grep-r WPS. And it is, running this tool, user local bin WPS check. So let's cat this. And let's see. There we go. So here's the pin, 1, 2, 3, 4, 5, 6, 7, 0. So I'm going to change this to 1, 2, 3, 5. And then we'll do 1, 2, 3. So 1, 2, 3, 5, 1, 2, 3. Okay, and the checksum is definitely going to change. So let's see. This becomes, let's just type it out real quick. I probably should grab this tool, WPS Pin. Can I easily just run this? I have to run the program. That's not the one I was looking for, but let's just calculate manually. 1, 2, 3, 5, 1, 2, 3. So this becomes 3, 2, 6, 4, 3, 2, 9. So 3 plus 2 is 5, 11, 15, 18, 29. And then that'd be 9 mod 10, which is 1. So this pin should just be 1, or the checksum, as long as we did that correctly. Okay. And let's see, that was in a service, right? We can probably do service WPS check restart. Okay, let's run that same Reaver command and see if this fails. Okay, it did fail. Sweet. So we have successfully changed the pin, and we can see it doing the brute force. And it got rate limiting, so it's going to wait a minute, but we can see it went with, let's see, trying pin 1, 2, 3, 4, 5, 6, 7, 0. Now it tried all zeros, 1, 2, 3, 0, 1, 2, 3. And then the next pin it tries is, I don't know, because it has to wait a minute. Let's set the pin to be 4 zeros first, so we can see this one work. So let's do another SU. I have to get the password. And after this, we'll wrap up the video to make sure everything works. Hopefully you enjoyed this Beyond Root segment. But yeah, SU dash, put this in, V, user local bin, WPS check it was. And we want to do 4 zeros. And now this becomes easier to check the pin. 0, 1, 2, 3, 4, 1, 2, 3. So This is 0, 0, 0. So the first 4 zeros, and then we multiply by 3, 2, 9. There we go. So that is 3 plus 2 is 6. 3 plus 2 is 5. Plus 9 is 14. So the pin is going to be 6. Let's see. 6, 6. And why they multiplied every other character by 3, I have no idea. That's right, right? 1, 2, 3, 6. 3, 2, 9. Yeah, that looks fine. Then service restart WPS check. Was that the service? Service restart. Oh. I was thinking I was typing systemctl. There we go. So now when we run Reaver, see, we did not get the pin, but we can see it definitely changed logics. So the first one, 1, 2, 3, 4, 5, 6, 7, 0. It got the Nack. Oh, I guess it failed Diffie Hellman or something here. So now it tries it. We get to M4. We get the Nack. So 1, 2, 3, 4. Okay. And then it tries 0, 0, 0, 5, 6, 7, 8. Remember, our pin started with 4 zeros. We didn't get past message 4 here. So this message, we get past 4, get 5, get to 6. The second half of the password is wrong. So now it's going to try again with 4 zeros. And then we still get to 6. And then we get rate limiting. So the next one again, it's going to again try to brute force with 4 zeros. And then we'll see what the next 4 are. So I'm just going to speed up. Oh, I don't have to speed up the video. But you can see the Reaver tool is very confident that the first 4 are correct because it progressed past M4. And it's just trying to brute force that last 3. And I say 3, not 4, because again, that last digit is a checksum. So I could do 3 times 3 is 9. So it's going to be 9 plus 3, which is 12. Right? Yeah, 9 plus 3 is 12. Plus 9 is 21, which 1 mod 10 would be 9. So that's how it's calculating that last number. So hopefully that makes sense and you've enjoyed everything. Take care, guys, and I will see you all next time.